This is not only mathematics, right? So this is logical reasoning. So if the number of old visitors buying platinum tickets was equal to the number of middle-aged visitors buying platinum tickets, then this is what we come up with. So 2x is 8 into 10 minus y, and this is the total number of platinum tickets sold. This is 2x, and your options are 34, 36, 38, 32. Which of these would be your answer and why? Anyone? Guys, can you hear me? Hello?
Yes, sir.
Okay, I sometimes feel that I'm disconnected. Okay, so anyone wants to attempt this? What does logic say? 2x has to be a multiple of 8, right? So which of these is a multiple of 8? 32. So that's your answer. Clear? Okay. Second question. If the number of old visitors buying platinum tickets was equal to the number of middle-aged visitors buying economy tickets, then the number of old visitors buying gold tickets was what? Old platinum equal to middle-aged economy. So old platinum is 20 minus 2y, middle-aged economy is 17 minus y. So these two has to be same now. So 20 minus 2y is 17 minus y. Twenty minus 2y equals 17 minus y. So that means y equals 3, right? Y equals 3. Then the number of old visitors buying gold tickets, old and gold. So old and gold is y, so that would be 3. Clear? Next one. If the number of old visitors buying gold tickets was strictly greater than the number of young visitors buying gold tickets, so old gold greater than young gold, then the number of middle-aged visitors buying gold tickets was what? Old gold greater than young gold. Look at the table again. Old gold is y, young gold is 42 minus x. So y is greater than 42 minus x. So that means x plus y is greater than 42. So middle-aged and gold is 43 minus x plus y. So 43 minus of x plus y will be what? So x plus y is greater than 42. So that means minus of x plus y is less than minus 42. So 43 minus of x plus y is less than 43 minus 42, which is equal to 1, less than 1. So that means the number of middle-aged visitors buying gold tickets has to be 0, because it has to be an integer. Okay. Which of the following statement must be false? Number of gold and platinum tickets bought by young visitors were equal. Young visitors, gold and platinum. So if young visitors bought gold and platinum in equal numbers, so x equals 42 minus x, that means 2x equals 42, x is equal to 21. So if x is equal to 21, then the other values can fit in. So there is no problem there. So this can be true. Number of middle-aged and young visitors buying gold tickets are equal. Middle-aged and young and gold. So middle-aged and young gold. So these two are equal. So 42 minus x minus y equal 43 minus x minus y equals 42 minus x. That means 43. So 43 minus x minus y equals 42 minus x. What does this mean? This means y equals 1. So that is also possible. No problems there. The third one, old and middle-aged visitors buying platinum tickets were equal. Old and middle-aged visitors buying platinum tickets are equal. So 20 minus 2y equals x plus 2y minus 20. So 20 minus 2y equals x plus 2y minus 20. So that means x plus 4y is 40. Right? So we already saw that is possible. That was the first one. So no problems there. And the last case is old and middle-aged visitors buying economy tickets are equal. So old and middle-aged visitors buying economy tickets are equal. Y equals 17 minus y. That means 2y equals 17 or y equals 8.5. Now this is not possible because y has to be an integer. The number of tickets bought and sold has to be an integer. So the last case cannot be true. So this is the case that has to be false. Is it clear for everyone? Yes, no?
Yes, sir.
Yes, sir.
Okay. So this is an example of a question which was pretty simple, because just by looking at the numbers, the variables, I knew that it's only 9 variables. So with 3 or 4 clues, I should be able to crack it. That's how you have to judge which question to go for. Okay, we go to the next one. Now I try to give you flavors of different kinds of questions because you need to know which one to attempt and which one not to attempt. That's a very important thing, because if you start with the wrong question and end up losing time, you will not have time to recover. Okay, now look at this one. An agency entrusted to accredit colleges looks at 4 parameters: F, faculty quality, that's F; R, reputation; placement quality; and infrastructure. So F, R, P and I, the 4 parameters used to arrive at an overall score which the agency uses to give an accreditation to the colleges. In each parameter there are 5 possible grades given, each carrying certain points. Okay. In each category there are 5 possible grades given, each carrying certain points. A is 50, B is 40, C is 30, D is 20, F is 0. So this is for every category. The overall score for a college is a weighted sum of the scores of the points scored in the 4 parameters, and the weights of the parameters are 0.1, 0.2, 0.3 and 0.4 in some order, but the order is not disclosed. So do not assume that F is equal to 0.1, R is equal to 0.2, P is equal to 0.3 and I is equal to 0.4. So this is the catch in the question. So the order is not disclosed, so we have to find out the order. Accreditation is awarded based on the following scheme. So if the score is greater than equal to 45, it's AAA, between 35 to 45 BA and so on. So this is how they are scored. Now 8 colleges apply for accreditation and receive the following grades in the 4 parameters. So the table is given and there are 3 conditions given. High Q is better than Best Ed, Best Ed is better than Cosmopolitan, and Education Ed is better than A1. Okay. Now first things first. So how many variables are there in this case? We have 8 colleges and then they are rated on 4 parameters, and then each parameter has 5 variables, and then on top of that I have I have to figure out the weightage also. So that means I am getting a number of variables as 20 into 8, which is 160, right? So this question is not a very simple one. So this should be clear to you. Okay, it will take some time. So let's see. Okay, so that means I have to create a table which will give me the scores. Okay, but before that I have to decide on the weightage. Weights are 0.1, 0.2, 0.3 and 0.4. Now I have to decide between F, R, P and I, which weight goes to which one. So for that, let's look at the clues. High Q is better than Best Ed. So we are comparing Best Ed with High Q. Now if I look at their grades, so for F the grade is B and C, for R it is C and D, for P it is D and D, and for I it is D and B. So except P, which are same, I cannot really compare anything, because if High Q has to be more than Best Ed, then the overall score has to be greater. That means C multiplied by the weightage has to be plus D multiplied by the weightage plus B multiplied by the weightage has to be greater than the scores here multiplied by their weightages. So I cannot directly get anything from here. So the next thing is bested is better than cosmopolitan. So now this guy is better than this. So that means high Q is better than bested is greater than cosmopolitan. So that means let me compare high Q and cosmopolitan. So high Q has to be more than cosmopolitan. So now between cosmopolitan and high Q, this is BC, DD, DD and CB. So that means these two scores are same for both, right? So there is no difference, whatever is the weightage. So the difference comes here, BC and CB, and high Q is better. So that means for C you get 50, 40, 30, 50, 40, 30, 20 and 0. So for C it is 30. So that means 30 into whatever is the weightage for F plus 40 into the weightage of I is greater than B is 40F plus D is 20I. So that means 20I is greater than 10F. So that means 2I is greater than F, right? So this is what we are getting from this comparison. So which means that despite getting a lower score in F, right, it has scored more than C, cosmopolitan. That means the weightage of I in which it has got a bigger score has to be more than F. Clear? So this is what you have to conclude from this. So the weightage for I has to be greater than the weightage for F. Okay. Next, we compare between between H and C. So we compared between we'll compare between B and C. Now between B and C, you can see that these two are same, these two are same. So the difference is between R and I. So that means B is greater than C. That means B has got a better score in R. So the rating for so the weightage for R has to be greater than the weightage for I. So between these two, I can say R is greater than I. Clear? Right? Now I compare education aid and A1. So looking at education aid and A1, I can see these two are same, these two are same, and the difference is in P and I. So that means E is greater than A. That means E has a better score in I, and therefore the weightage of I has to be more. So I has to be greater than P. So these are the three inequalities that I conclude. So that means if I put everything together, I is greater than both P and F, and R is greater than I. So I can write I R greater than I greater than P greater than F, or R greater than I greater than F greater than P. These are the only two cases that are possible. Clear? Clear up to here? Okay. So now we have got this part. So this has to be, it has to be either of the two cases. Now let us consider the two cases separately. So case 1, this is case 1 and this is case 2. So if it is case 1, then let's compare the scores of high Q and bested. So high Q score will be C in F, right? So in case 1, R is 0.4, I is 0.3, P is 0.2 and F is 0.1. So now let's put the scores. So high Q will be F into, F is 0.1 into C, that's 30 into 0.1 30 into 0.1 plus D in R, R is 0.4, D means 20, 20 into 0.4, D in P, P is 0.2, 20 into 0.2 plus B in I is 0.3 and B is 40, so 40 into 0.3. So this comes out as 3 plus 8, 3 plus 8 plus 4 plus 12. So that's 27. And bested becomes B in F, that means 40 into 0.1 plus C in R, that means C is 30 into 0.4 plus D in P, D is 20 into P is 0.2 plus D in I plus D is 20 into 0.3. So this comes out as 4 plus 12 plus 4 plus 6, which is 26. So HQ is greater than B is correct. Now B is greater than cosmopolitan. So cosmopolitan will be B in F, that means 40 into 0.1 plus D in R, that means 20 into 0.4, D in P 20 into 0.2 plus C in I 30 into 0.3. So that gives us 4 plus 4 into 2 point, so this is 8 plus 4 plus 9. So 8, 9, 17, 21, 25. So this is 25. So that means HQ greater than B greater than C is okay. Now E is greater than A. So So E will be A in F, that is 50 into 0.1 plus A in R, right? So actually we can ignore these two would be same, so we can just compare the third and the fourth. So B in P, that means 40 into P is 0.2, and A in I, that means 50 into 0.3, which will be 8 plus 15, which is 23, and A would be A in P, that means 50 into P is 0.2 plus B is 40 into I is 0.3, which is 12 plus 10, which is 22. So that means this order fulfills all the criteria that are given, right? So this should be the correct order. Is it clear? Clear for everyone? Okay. So that means this is what we get. R is 0.4, R is 0.4, I is 0.3, P is 0.2, and F is 0.1. Now you have to make the full table to get the scores for each one of them. So F, which means 0.1, R, which means 0.4, P, which means 0.2, and I, which means 0.3, and then you get your total score based on this, and then based on that you will get the rating. So A, B, C, D, E, F, G, H. A will be A into 0.1, that is 50 into 0.15 plus 50 into R, which is 0.4. So that's 20 plus 5, 25. So this would be 50 into 0.1 is 5, 50 into 0.4 is 20, then 50 into P, which is 0.2, 50 into 0.2 is 10, and 40 into 0.3 is 12. So the total score will be 20 plus 12, 32 plus 10, 42 plus 5, 47. B will be B into 0.1, that is 40 into 0.1, which is 4. C into, that is 30 into 0.4, that's 12. D into 0.2, that is 20 into 0.2 is 4, and 20 into 0.3 is 6. So the total will be 12 plus 8, 20, and 6, 26. Then C will be B into, that's 40 into 0.1, that's 4. Then D is 20 into 0.4, that's 8. Then 20 into 0.2, that's 4. Then 30 into 3.3, that is 9. So 17, 21, 25. D will be 20 into 0.1, that is 2. Then 20 into 0.4, that's 8. 20 into 0.4 is 8. Then 40 into 0.2 is 8, and 30 into 0.3 is 9. So 16 plus 9, 25, and 2, 27. Then E would be A into 0.1, that's 50 into 0.1 is 5, then 50 into 0.4 is 20, then 40 into 0.2 is 8, then 50 into 0.3 is 15. So 20, 15, 35, 40, 48. F is 50 into 0.1 is 5, 50 into 0.4 is 20, 40 into 0.2 is 8, 40 into 0.3 is 12. So that's 20 plus 20, 40, plus 5, 45. Then G would be C, that's 30 into 0.1, 3, F is 0, D is 20 into 2, 4, 20 into 3, 6, so 13, and H. C is 30 into 0.1 is 3, 20 into 0.4 is 8, 20 into 0.2 is 4, and 40 into 0.3 is 12. So 20 and 7, 27. So these are my scores. Now I go back to the table and see what are my accreditations. So greater than 45 is AAA. So let's mark the ones greater than equal to 45. So this is AAA, then this is AAA, this is AAA. That's it. Then between 35 to 45 is BAA. 35 to 45 we don't have any one. Okay. Then 25 to 35 is BBA. 25 to 35 including 25 is BBA. BBA, 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 and BBA. So 1, 2, 3, 4, 5, 6, 7. The last one is 13. 13 will be less than 15, so that's junk. So that is junk. So now my table is ready. So now we go for the questions. What is the weight of the faculty quality parameter? So faculty quality parameter is F. So F would be 0.1. How many colleges receive the accreditation of AAA? So AAA is 1, 2, 3. What is the highest overall rating, overall score among the 8 colleges? Highest score among the 8 colleges is 48. And then how many colleges have overall scores between 31 and 40, both inclusive? 31 to 40. There is no college between 31 to 40. Clear? Is it clear? Yes, no?
Yes, sir.
Okay. So as I said, this one took a little longer than the previous one because in the thumb rule itself it told me that this is going to take longer. So this is not a very difficult question, but it is a little calculation intensive. So you should pick this after you have completed the easier ones. Okay, the next one. Fun Sports provides training in 3 sports: G, K, and L. Currently, it has an enrollment of 39 students, each of whom is enrolled in at least one of the 3 sports. The following details are known: the number of students enrolled only. Okay, so by looking at the question, so can you tell me how many variables are there? Anyone? So it's talking about 3 sports, and if you see the clues, number of students enrolled in only L, all 3 sports, enrolled in G, etc. So this is a question based on Venn diagram. Okay. So I represent this by G, K, and L. So G, K, L. Okay, and the total number of students are 39, and each of whom is enrolled in at least one of the 3 sports. So total of everything is 39. Number of students enrolled only in L is double the number of students enrolled in all 3 sports. So let the students enrolled in all 3 sports be X. So the number of students enrolled only in L is 2X. There are a total of 17 students enrolled in G. So the total of G has to be 17. Number of students enrolled only in G is 1 less than the number of students enrolled only in L. So only in G has to be 1 less than L. Number of students enrolled only in K is equal to the number of students who are enrolled in both K and L. So I don't know how many are enrolled here. Let me assume this to be Y. So this will be X plus Y. Maximum student enrollment is in L. That means L has to be greater than both K and L has to be greater than G. 10 students are enrolled in G are also enrolled in at least one more sports. That means the sum of this and this has to be 10. Right? So if I call this as A, so this would be 10 minus A minus is 10 minus A plus X. Right? Now this is all that I have. Now there is one more clue that the total is 39, so which I have not used yet. So total is 39 means okay, there are two things. The total out here, A plus X plus 10 minus A plus X is 10. So this is 10 here, and this is 17. So 17 is 2x minus 1 plus this 10. So 2x minus 1 plus 10 is 17. So x will be 17 minus 10 plus 1. So that is 8. 2x is 8, x is 4. So now I have got the value of x. So let me replace all of this. This is 4. This would be 7. This would be 8. And this would be 10 minus a minus 4, that is 6 minus a, and this would be 4 plus y. So now I'll use the second condition, that the sum total of all of this will be 39. Now the sum total of g, which means all of this included, is 17. So 17 plus 8 plus y plus 4 plus y, all of this adds up to 39. So that means 2y will be equal to 39 minus 25 plus 4 is 29, that's 10. So y is 5. So now I got the value of y also. So let me replace y. Okay. So this is my these are my figures now. Okay. Now let me also calculate the value of k. Total of k will be 9 plus 4 5 14 plus 4 18 plus a, and L is 5 plus 8 13 plus 4 17 plus 6 23 minus a. Now there are two more conditions that I have still not used, which is L is the maximum. So if L is the maximum, then this has to be true. So L is greater than k means 23 minus a has to be greater than 18 plus a. So that means 2a has to be less than 5, or a has to be less than 2.5. Now a has to be an integer, therefore a can take values of 0, 1 and 2. Right? The second condition is L is greater than g. That means 23 minus a is greater than 17. So that means a is less than 6. Now this is redundant because I already have a is less than 2.5. Clear? Is it clear?
Yes, sir.
Okay. So before I go to the questions, let me now, since a is my only variable, so let me make a small table. So a can take only three values, 0, 1 and 2. So based on that, let me find out the values of g, k and l. Now g is constant, it has to be 17 in all three cases. Now what about k? K is 18 plus a. So if it is 0, then k remains on 18, and if it is 1, then 18 plus 1 is 19, this is 20, and L is 23 minus a. So if a is 0, then this is 23, if this is 1, this is 22, if this is 2, this is 21. So these are the only three sets of values that are possible. Now let me go to the questions. What is the minimum number of students enrolled in both G and L but not K? Minimum number of students enrolled in both G and L but not K. Right? G and L but not K refers to this part, 6 minus A. Okay. So the question is, what should be the minimum value of 6 minus A? What should be the answer? What should be the answer? If 6 minus a has to be minimum, a has to be maximum, and a can take only 3 values here. So the maximum value of a is 2. So the minimum value of this will be 4. Right? Clear?
So please repeat.
The question is, what should be the minimum number of students enrolled in both G and L but not K? Now G and L but not K, as you can see from this, is this part. This is the area, the overlap between G and L but not K. K is here. If it is said G and K but not L, then this would be the region, and this is all three, right? So G and L but not K is this 6 minus A. So the question is, what should be the minimum value of 6 minus A? Right? Now 6 minus A will be minimum when A is maximum. You can see there are 3 values of A, 3 possible values of A, 0, 1 and 2. If I put A equal to 0, 6 minus A will be 6. If I put A equal to 1, 6 minus A will be 5. If I put A equal to 2, 6 minus A will be 4. So the minimum value of 6 minus A has to be 4. Clear?
Yes, sir.
Okay. If the number of students enrolled in K and L are in the ratio of 19:22, what is the number of students in L? Now you look at this table that I have made and you will get the answer. So the possible values are this. These are the only set of values that are possible, right? Either K is 18 and L is 23, or K is 19 and L is 22, or K is 20 and L is 21. So it is given that the ratio of K and L is 19:22. That means they are talking about the second case. So what is the number of students in L? L would be 22. Is it clear?
Yes, sir.
Okay, so we stop here for today. We meet again next week. Okay, take care. Bye.